Thank you, Ashley. I don't have any PowerPoint for you today. We're not going to waste any time with that. First thing I'm going to talk about is what are dynamic blocks. Some of you might have seen them in the past. Some of you might have never seen them. You might have seen them, but don't know exactly how they work. Essentially, as we know, with standard AutoCAD blocks, it's a group of objects. Doesn't matter if it's lines, arcs, circles, rectangles, whatever you want it to be, combined into one object. We call it a block. Sometimes it's called a symbol. Now, blocks, since they are one object, can't be modified. You know, there's some things we can do is we can rotate them, we can scale them, we can change attribute text on a regular block, but it's not like you can stretch certain aspects of it. It's not like you can designate certain distances in between lines that you create. And when you have blocks such as a bolt, a door, a switch, there's a lot of different variations of those. And that's what a dynamic block can do for you. You're gonna see in an example I'm going to show you how you can take, you know, one single block that you might have had to represent 30 blocks, just 30 different variations essentially of the same thing. Before dynamic blocks, you would have had to create 30 different blocks. With dynamic blocks, you can create one block and then choose some of the different parameters that allow you to change that block. It might change the size, you might change the part number on it. And dynamic blocks can be overwhelming. I'm going to show you some examples, and then we're actually going to do a couple as far as building them from a simple one to an extremely complicated one. And it's up to you what you build into those. I call dynamic blocks, you know, we call them, there's different parameters that you can set for them. I just call them, you know, what rules do you build in to the dynamic block? It's all up to the user on how they want it to be. You decide what those rules are. And why do we use them? First, before I go to that, an example of a dynamic block, and I'll do a couple of these as well, would be something like this, where you have a bolt. You know, in the past, the top bolt here and the bottom bolt here would have been two separate ones. I can create one where I can change to different sizes. Here's a switch. I'm an electrical guy. Here's a switch that you can use in an electrical drawing. It's one block, but it's represented two different ways because I built rules in it to show me what a normally open is and what a normally closed is. And why do we use them in the first place? Big reason is it can reduce the number of blocks that you would have in your standard library, plain and simple. Not all the same blocks have all the different features as far as the different modification feature. I go back to rules. It's up to you what rules you want to build into the dynamic block itself. And you're going to see that here this morning. I'm going to insert a whole bunch of different ones. Every single one has different rules behind it. The one thing you want to look out for too, if you've never even used a dynamic block at all, are grips. In a standard block, you know what a standard grip is. When you highlight a dynamic block, you're going to see all different types of grips on there. Each one of those grips are those rules that I keep referring to. You decide what you want to modify with that. And out of the box, and I'm going to use those, you have several dynamic blocks to use, to choose from. When I first started creating them, a lot of times I would try to start with a sample that was out of the box in order to build mine around. That just made it a little bit easier when I keep referring to the parameters and the rules. It was easier to create that way. So as an example, if I open up, I'm going to start with a regular block. I'm just going to open up Design Center real quick here. and I'm going to insert a bolt into this drawing. This bolt is a standard AutoCAD block. It's got one grip on it, that's it. I can't make this longer. I can't make the physical size of it bigger. I can't switch to a part number on it. It's a block. It is what it is. That's what they were meant to do. Now with a dynamic block, I've got my tool palette. This is just the standard AutoCAD tool palette that I opened right here, like always. I'm going to insert this hex socket bolt. And as I insert it, I'm going to rotate it 90 degrees, or minus 90 in this case. And I'll just put it off to the side over here. And when you're using the AutoCAD tool palette out of the box, anytime you see the lightning bolt sitting next to a block, that means it is a dynamic block. Now, if I take a look at this, a closer look at this, if I select this block, look at the different grips that I have available. I've got the standard one here where I can move it. That's the base point of the block when somebody created it, no different than you're used to now. But down here, if I select this grip, this shows me the initial length of the bolt. You're going to see all those little hash lines. Notice as I drag my cursor up or down, they're getting locked into the specific distances. So yeah, I can make this shorter, I can make it longer, but whoever built the block built in that I make it shorter or longer at 5 increments. That's why it's 45, 50. I can't go anywhere in between. And that's somebody built those rules into the block itself. If I come up to this grip right here, I've got some different options as far as sizes are concerned. If I choose an M3, it automatically changes it to that size. M5. These are all the different choices that I have to change the physical size of the socket bolt. The one that I want is an M12. So if you think about it, I would have had to create 8 different blocks just to represent this one that has different sizes. And that's the whole point of this. Reduce your library size. Now, some people, if you really get into this, you want to be careful because you can really go crazy. I'm gonna put another bolt in here where there's 50 different varieties of it. You know, sometimes you have to rethink, you know, am I really going along the right path here? Because that is a time investment. If it's worth the time investment, then by all means do it. But that's up to you to make that decision. Now I can treat this just like a regular block. I'll move this, and actually before I do that, I'm getting a little ahead of myself, but if I edit this block, all dynamic blocks are created through the standard AutoCAD block editor. So if I pick OK here, it just gives you a little insight into what has to go into it when you create it. I'm going to create 2 different ones. You're going to see me use some of these same tools. But look at the hashtags. Those were set up specifically for the length and the different sizes. And you see these over here. You know, this tells me to stretch it at certain increments, as you can see. This one down here is another stretch. This one over here is what we call a block table. That's where I was able to choose the different sizes. I'm just going to close that out. And I'm going to take the block, and in this case, I'm going to move it to the midpoint over here. And to change the length of it, I'm going to make it a little bit longer. These are metric. And then I can take this block and treat it just like any other block, any other AutoCAD object. In this case, I'll copy it from here over to here, and I'm up and running. Another example of a bolt, let's say, here's a shoulder screw. And if I pick this and just put it in the middle of nowhere, as you're going to see, this is the one I was referring to. There's 50 different sizes that I could choose from right from here. Now, obviously, whoever created this would be a time investment. That's where you have to make the decision. Is it worth that time investment, or can I go about it a little bit different way? But I could choose a different size, and then just like the other one, I could change the length. And again, notice that they're set for specific increments on the length. And I could change it to, let's say, 1/4 20 as well. Somebody built all those rules into that particular dynamic block. If I go over to my electrical drawing and I select the electrical tab, these are all still out of the box. First of all, I'm an electrical guy for the most part, so hopefully not a lot of you are using regular AutoCAD for your electrical experience, and I won't go too much off on that, but take a look at AutoCAD Electrical instead of just AutoCAD. But if you are using regular AutoCAD still for your controls or electrical drawings, you know, great idea for dynamic blocks. I'll insert one, let's say right here. It's just a normally open contact. But since it's a dynamic block, and this is about as simple as a dynamic block as you can get. It's either an open or a closed. But it saved me from having 2 blocks instead of 1. And it's nice to be able to just put one in and kind of toggle it like that. If I were to open up this in my block editor, whoop, as you can see, there's not nearly as much going on as there was with the bolt. It all depends on what you put into it. Completely up to you as you're creating it. Another example might be a limit switch. Place this one down here and it's the same exact idea. Whoop, didn't quite put it in the right spot, but no biggie. I could change this from an open to a closed. If I had an architectural example, here's my architectural tab, and I'll insert, let's say, a door. And I'll drop it out in the middle of nowhere. And if I want to place it, I'm going to place it in this particular opening. Whoop. Let me just move that down. Turn my object snap on, make it a little bit easier. So as you can see, this would be popular in an architectural environment. You've got doors. Well, you've got all kinds of door widths. You've got different door openings as far as the angle is concerned. This one is too big right from the get-go. So if I select it, I can come here. That changes the opening. If I come here, that flips it as far as the orientation. If I select here, now I can change it to the proper size. And then if I did want to change the opening to like 90 degrees, you know, that would have been 8 different blocks that I would have had to have stored in my library just for that one. And then you can get into different, if I insert this toilet as an example, just put it right on the wall here. If I select it, and if I want to flip it, that's an easy one. But if I select here, I can have different views of the toilet. So maybe it's an elongated side view. Maybe it's an elongated plan view. If it is a plan view, I have another dynamic block grip on here that I can grab and flip it over that way. Maybe it's a pull chain. You know, you can change it to anything you want. And again, flip it around, and then from here, again, I could rotate it. I could do whatever I want. If I open this up, you know, this looks pretty simple from here, but there's a lot of effort that's put into that. Now I'm going to go over to the bank layouts drawing here, and I'll go over to this section. And the first thing I'm going to insert here is this drawing title, Imperial, and these are just tied to my viewports. And I'm just giving you different ideas with some samples here that you can work with. I could copy that to every other view. And then mainly what this dynamic block does, when I select it, I can pick on this dynamic block grip and stretch it out to the length of the viewport and do each one. And they're still blocks, meaning, you know, if I double click on this, I can still adjust attributes like I do all day long. That's the thing to remember. You're going to use all your block knowledge and then just add on top of that. If I had, let's say, the section call out, I'll just drop it down right here. This one has a rotate option built right into it, as you can see right here. And look how many direction or angles that I could rotate this on. Looks just like your polar tracking at this point. It's not. These are rules that were built into a dynamic block. I rotated it all the way along, but my text, my bubble, stayed in the same shape that it was originally. That's because that's how it was built into the dynamic block itself. I could stretch this all the way across, and it's got a little flag on the end of it out there. I could turn the flag off if I wanted to. So that might replace, you know, with the amount of rotation angles on there, who knows, 20 blocks I just replaced out of my library with one. So these are some of the samples or examples that you can use dynamic blocks in. Now, how do we create them? I'm going to create a simple one, and I'm going to create a complicated one. And this is where you get into the rules themselves. Now, by default, even if I use a create block command, I'm going to do it in the block editor because that's where my tools are. That's where my rules are that I can choose from. We have parameters, we have actions. Parameters are similar to dimensions, but they control the block geometry itself. So like with the bolt, we'd add a linear parameter to define the length, to be able to adjust it. Actions are added to parameters so that you can modify the parameter in the completed block. I'll go back to the bolt example. The linear parameter specifies the dimension that you want to control. Then you can add a stretch action to that parameter so that you're able to stretch the bolt to the required length. I'm going to do that right here with this receptacle outlet. I'm going to stretch it so I have the ability to create, you know, a 2-banger outlet or a 3-banger outlet. Now, this right now is just lines, it's graphics, lines, arcs, circles, what have you. So I'm going to create a block from scratch here. I'll go to Insert, just go to my standard Create Block. and I'm going to call this receptacle cover. Oh, let me do this. Base point, just like you always would. I'm going to choose the center of my hole here. Select objects like you normally would. Pick all my graphics. And I'm going to make sure that this is checked on down here. I want this to open immediately in the block editor. That might be different than when you create a standard block. You don't need to be in a block editor to create a standard block, but we do need to be in it for dynamic blocks. So I'll pick OK here. Now here is what I was referring to with parameters and actions. When I go to parameters, as you can see, this is the first item that's added to a dynamic block. They define any aspects of the geometry that you want to control with the actions. So I can put a simple point on here. I can draw a linear one, which I'm going to do, a polar. I can build in the rotate like you just saw with that other dynamic block. You saw me flip one. These are the parameters. Once you establish a parameter, then you want to tag an action to it. What do you want to do with that distance? What do you want to do with that parameter? And a lot of these are going to look familiar to you as far as, straight up AutoCAD commands. So you must use actions to associate to the parameter. And what you would typically do, and what you're going to see me do here in a minute, is when I choose the stretch parameter, when I choose the array parameter, I'm going to pick directly on, or my action, I'm going to pick directly on the parameter that I put in previously. Now, when you get comfortable with this, we also have parameter sets where you can put in both at the same time. That can make it a little bit easier, a little bit faster. I'm also going to do an example where I'm going to take advantage of constraints to build into a dynamic block. So I'm going to go back up to parameters right now, and I'm going to start with a linear. And I'm just going to, just like putting a dimension down, give me a linear from the endpoint here to the endpoint on the other side. And I'm just going to drag and drop this into place right about here. Now I have to associate an action to that parameter. So I'm going to go to actions. And I'm going to start with the stretch action. And I'm going to select the parameter that I want to link this to, which is this distance. And then if you notice at my command prompt, it says specify parameter point to associate with the action. I'm going to pick, once again, the endpoint of the line on the right over here. And then it's asking me for my stretch frame. Think of the stretch command in general. We establish the action first, then we actually apply the stretch command to it. And what I mean by that is, my stretch frame, I'm going to pick here over to here. In this case, I want to stretch out the right side of this. I'll hit enter, and then it's asking me to actually create the stretch. This would actually do the AutoCAD command itself. I'll hit enter. And now, as you can see, I put this up here, letting me know that this stretch action is associated to this particular parameter. Now from here, I'm going to close the block editor, and I'll save the changes. So now when I select the block that I just created, notice that I can stretch this out. But there's really no rhyme or reason at this point. This is what we have to fix next. I'm going to undo here. And then I'm going to go right back into my block editor. And then I'm going to set up some specific increments for this. So I'll pick the distance parameter once again, and then I'm going to go to my standard AutoCAD properties. From here, for the value set, I'm going to change the type to increment, and I want the increment distance to start out at 1.8. And then I'm going to follow that up with 2.8. And then the distant max, I'm going to go with 6.4. You can see the little hash marks that came in. That's the 1.8 to the 2.8 with the max of the 6.4. Just going to hit escape to unselect that. I'll save this again. Now when I select it, now it's being forced to either go, 2.8, 4.6, 6.4. Those are the rules that I'm building into this, and that's the whole point. I'm still missing one thing. My holes for my receptacle didn't carry over. Obviously, I'd want that as part of the dynamic block. We'll modify it one more time. And then from here, I'm going to go back to actions over here, and I'm going to select the array. Once again, I'm going to pick on the same distance parameter. Hit enter. Select objects. I want all my holes that represent my receptacle. And then I want the distance between them to be just like the values were, 1.8. And notice that it added this other one up here. I'll close this, save it. Now when I select it, I can represent multiple outlets instead of just the one. And obviously I could have built that to go to the left. I could have built it to go up. I could have put all three in there. It just depends on how complicated, how many rules that you want to build into it. Now the next one I'm going to do is create a dynamic block with constraints. This would be considered, let's say, a complicated one. Now when I open this drawing up, this is already a block. It's a standard AutoCAD block. It's a bookshelf. That's what it's supposed to represent. Well, obviously you could have a lot of different variations of this bookshelf as far as width, height, the physical size of the shelves themselves, specific parameters as far as distances are concerned. There's all sorts of things I could build into this. Now, if I double click on it, because it is a block already, I'll pick OK, and it takes me back into the block editor. I'm going to shut my properties off for now. I'll shut the tool palette off for now, because that's just getting in the way. And then the first thing I'm going to do here is I'm going to check my constraints to make sure when I go to auto constraint, everything is on with the exception of equal. Then I'm going to go to my auto constraints command, and I'm going to pick everything. And then I want to lock these into their specific position, and I want that position. So if I come up here, I'm going to pick fix, and I want it to be on the end point of the line right here. And now, just like always, I don't need to be staring at my constraints all day long, so I'm going to pick hide all. And then I'm going to start with a linear dimension, let's say, with the constraints. And I'll pick the end point here to the end point here, drag this up to here, and drop it in. Nice part is, it's not like I'm dimensioning something, so I don't really care what it's going to look like at the end, because all of that is hidden in the background when I actually insert the block as a normal block. I'm not going to see any of this stuff, obviously. I'll put another one down. And this time I'm going to go from the end point here. Got to be careful sometimes that you're getting the right constraint, obviously, to here. And I'm going to drag this one out to the left. Now, when you do create dynamic blocks, whether they're very simple or very complicated, the nice part is you can test them as you go along to make sure it's doing what you want it to do. Right now, I'll go up to test block immediately. So it doesn't really boot me out of the block editor, but I'm allowed to test it if it was a normal block. So if I pick it, yeah, I can stretch it. But if you notice, it only stretched that particular outside line. Same thing if I wanted to change the height. That doesn't do me a whole lot of good at this point, but, you know, I'm checking my work. I'm making sure I'm on the right track. So I'll undo back to where I was and then close the test block itself. Now I'm right back into my block editor. Now I'm going to open up my parameters manager right here, and I'm going to change the name from D1 to width in this case, and then the D2 to height. I'm identifying what they are. And then I'm going to add 3 new user parameters. 1, 2, 3. And then I'm going to change the name and the expression next to it. So the first one's going to be, I'll call this half underscore thick. They work like attribute tags, so don't use spaces or special characters in here. Next one, I'll call it thickness. Next one, I'll call it shelf height. And then for the expression, I'll make this thickness divided by 2. I'm going to make this straight up 5/8, and then the height. This all gets tied back to my end goal here to be able to change the physical size of this with a few clicks that would normally have to represent many blocks instead of just one. Now, after I did add those parameters, I can always edit them like I just did. Now, I'm going to add some more linear dimensions or parameters, if you will. I'll go back up to linear here. And the first one I'm going to take from the endpoint of that constraint to the center line here. Accept it. I'll do another one. You got to make sure that you get on the lines and not the previous linear dimension. Just like if you were dimensioning anything else in AutoCAD. And then I'll put another one. From here to here. Now let me show you what happens if you try to over-constrain. Let's say I want one from the endpoint here down to the endpoint here. You'll get alerted. It'll tell you. You don't want to over-constrain. That's fine. So now we have the distances in between the shelves, but let's set up the thickness of the shelves themselves. So I'm going to come over here, and this time I'm going to force it to be vertical. And I'll select the constraint here to the constraint here, drag it out to here, drop it in. Do the same thing with each one, here to here. Go down to the next one. Put this one here. And then down to here. Then I'm going to test it again. Whoop, there we go. And then we'll go out to here. Now I'm going to change some of the names again. We're going to call the D1 shelf 1. And I'm save as much typing time as I can. I was never real good at that, so put this one in here, call it shelf 2. This one in here, call it shelf 3. And then as far as the expression is concerned, I want to change this to shelf height. And I'll keep it for each shelf. So let's take a look to see where I'm at right now. Pretty close. Not quite there yet. But let's test it. Now it's still, as you can see, it's doing more than it did before, but it's still missing a couple of constraints to get it to the point that I want. So let's go back. And now I'm going to put the rest of the constraints in here. I'm going to go back to linear. And I'm going to put one down on the bottom for both the height and the width between these two constraints. There's one. And we'll go from here to here. And then the other one I'll put in over here. And then I'm going to put one more in at the top. And we'll go from here to here. And I'll drag this one out to here. And then I'm going to take these center lines and turn them into construction lines. Just pick construction up top for each one. And I'll convert this. And let me just double check with my parameter manager to see what we got going on here. Now I'm going to modify those last parameters I put in plus the other ones. So in this case, for the expression for D1, 10, 2, and 3, we're going to call this thickness. And once again, I can use my clipboard to copy, paste, 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 and then 4 through 9, we're going to go back to the half thick. And we'll copy that. Paste, 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 and then finally the last one. So now the next step is where the magic really happens. And what I mean by that is I'm going to create a block table. This is where you're able to pull up a list like I did with the bolts, where I had a choice. You know, let's pick either the size or the part number as an example. We're going to dictate the different sizes that we want this to go to. So I'll go to my block table. And first thing I have to do is decide where I want to put that grip, is essentially what I'm doing. So I'm just going to say, let's put it close to here as an example. And I want the number of grips just to be 1. And what do I want to include in my table? I'm going to start with the width and the height. And then I'm going to add my own. And we're going to call this size. And the original value is going to be 30 by 60. And I want this to be set to string. And then I can also move these rows around, or these columns around. I want this to be the very first one, so I'm going to shove it over here. And then for the size, this will be all the different variations I want of this dynamic block. So as an example, we're going to go 24 by 36, which the width will be 24, and the height will be 36. And then we'll go, I'm sorry, this should have been 24 by 60. Next one's 30 by 60. Next one's going to be 36 by 60. Next one's going to be 24 by 72. I'm going to put 2 more in here. And then 36 by 72. And then I'll pick OK. Oh, I always forget to audit that. Let me go back to the table. You can see if you made any mistakes anywhere along the line, especially with the table. No errors have been found in the table. So now, let's say I'm done with my dynamic block. I'm going to pick Close Block Editor, save my changes. So now when I select the block, here's my list down here. Want it to be 24 by 60, it's 24 by 60. I want it to be 30. Do I want a 72 height? So just like that, you know, I'm replacing one block with 5 blocks based on the rules that I built into the dynamic block itself. Now, I could have built in as well, watch what happens. I can manually make this anything I want. Sometimes that's a good thing. Other times you might not want that. I could have built in to only allow it to go, obviously, to the specific increments that I wanted it to go, or from a particular table. One more I forgot to show you, I want to show you before I finish up here. I'll go back to my electrical drawing, since I'm an electrical guy. And this actually came from a customer. If any of you electrical people out there, Dipswitches, and you can use this inside of AutoCAD or AutoCAD Electrical. But how many times do you have different combinations of Dipswitches? Well, now I could select it, say give me 5 of them, and then you can dictate what's turned on and what's turned off. You know, maybe those 2 are on. Think of all the different combinations you would have as an example of a dip switch. This saves me from having individual blocks that are locked into either on or off, or how many I actually have. And this is a small one. I've seen people create them where there's 12 dip switches, whatever the case is. But this is the whole point behind dynamic blocks, why we have them. And the thing you just want to keep in mind is that you're building rules into them. I call them rules, but it's parameters and actions. Every parameter has an action, and as you saw, it might have a couple of actions as I was creating the receptacle. And like I said before, once you get good at this, you can put both in at the same time. As far as the constraints are concerned, I went straight up with whatever's on my block editor toolbar instead of using them over here. Okay, that's my spiel on dynamic blocks. I'm sure Dan's been answering questions. Ashley, you want to take it back over from here?
Sure. Thank you for the presentation. Again, we'll hold here for a little bit. If you think of questions, go ahead and enter those in, and we will get those going. And Dan, you can hop on in if there are any questions that you want to call out that have come in already. Go ahead.
Yeah, there's one question with regards to dynamic blocks being available in AutoCAD LT. And Greg, from what I was saying basically, is that AutoCAD LT can work and can create a limited variation of a dynamic block. It can't create the constraints or the geometrical constraint and dimensional constraint that you were using to resize any of the components. Am I correct on that?
That is correct. Yep. And that should still be the same way in 2020. I haven't looked at 2020 LT, but I would imagine it hasn't changed.
Yes, it's still on their Autodesk's website. It states the same thing.
Okay, cool. Looks like Dan's been doing a good job answering those questions.
Could you have a dynamic block inside of another one? So a dynamic block inside of another one.
I've never tried it, but my guess would be no, because if you put the dynamic portion inside of a regular block, now you're back to a regular block that you can't modify.
Okay. Is there a way that we can prevent text from being rotated while using or when using the alignment rule?
Yeah, I'm guessing you mean like when I put the one down here. Here's the text that's part of that balloon. When I rotate it, that text doesn't go anywhere. If you wanted it to rotate, then you could build that into there as well. So you have either way. You can set it up to do whatever you want as far as that's concerned.
Awesome. All right, the next question is, can we create dynamic blocks to work with solids like 3D models?
That, maybe you got an answer for that. I'm not a 3D guy, so I cannot answer that question. If Dan can't, then we'll have to get back to you on that one.
I have not heard of a dynamic block being used in a 3D, but that is something I can look into and we can find out. Okay.
I assume block values can be linked to database values. That part hasn't changed. If you're using attributes or fields, it works exactly the same. Can a constraint table be imported from Excel or SQL? That I don't know. Dan, do you know?
I've never seen that work, that type of interaction happening. I don't know if there's an import with the table functionality, but that's another one that we can definitely look into.
Yep, for sure.
Okay, so Tim, you had a question with regards to how to fix a block definition. We do have a support team that could actually help you. That's kind of a hard thing to kind of assist with you right now without having to look at it. So I definitely urge you to contact us through our service portal or services@hagerman.com, and we can definitely look into or getting some answers to you that way. Can text change dynamically? Are you referring to the height of the text? What do you mean by that?
Right. Because remember, it's still a block with attributes, let's say. And if you wanted to change the values of that, you would just go to your properties or your text options.
All right. All right. So look,
I don't think what would happen, I've never tried it. I can check on that one as well, but I don't think you would get, like, if I have the stretch action built in, that's what you're getting at, have it adjust the size of the text automatically. I'm guessing no on that, just because it.
Yeah, that's controlled by the actual attribute editor and the size there. Fields, can they be specified in dynamic blocks?
Let's see. Fields be specified in dynamic blocks. I would treat them just as you're treating them now. Remember, it's still a block. If we can specify fields in a regular block, we can certainly specify them in a dynamic block. And that's the one thing you want to keep in mind is these are still blocks. That's their That's their originator, let's say. That's where they started from. So anything you can do in a block, you can do in a dynamic block. It's just, what can I do with a dynamic block on top of a block is how you want to think of it. So obviously we can insert fields in regular blocks. So yeah, absolutely put them in dynamic blocks. Can you have different models in one dynamic block? For an example, let's think of cars. Can we have one Grand Jeep SUV and one Honda? Oh, absolutely. That kind of goes back to, the toilet example. Sorry to use that as an example, but.
Hey, Greg, if you bring up the tool palette, there's actually a car in the standard AutoCAD tool palette.
Right, that's right.
And you can show him that.
Yep. Let's go to, I'm just go to the model here. I got a blank space. And let me turn my tool palette back on. Is it on the tool palette or is it in Design Center?
It's in the tool palette. Let's see. Let's see if I can find it really quick. If you look in the architectural tab, it should be like the, maybe
right there.
Yeah, that one. So there's your Camaro. And then
go ahead.
And then you can choose the side sedan. That's the plan, yep. Go to the next section, like below it, where it had like sedan down there. Yep. So there's your four-door car. So yeah, and then since you could change it to represent that in a different, model.
Absolutely. It just goes back to what you want to build into that list that you see right here. And instead of views like you see here, I mean, he's exactly right. You got the sports car, you got the sedan, got a nice truck. Those could be your different models. Or you could make the list to spell out Chevy, Ford. You can even put the, model number that's on there. Whatever you want that list to be in relation to what shows up here. And that's one of the main points behind the dynamic blocks. Absolutely.
Okay, so there is one more question that I'm not sure how to answer, but it says, can one change to 2 to 3 as you add blocks? So I'm not sure, Michael, what you mean by that.
One change to 2 to 3. I'm not quite sure either. I mean, if it's something like the cover plate, if this is what you meant, I started with 1. Now I got 2. Now I got 3.
Back to the text sample.
Which one was the, oh, okay.
So you're talking about the section number at the top. Those are attributes just like you normally would have in a block where you can change that. Yes.
Yep. But if you're still talking about, can you change, the size of it, there is no action to have it automatically adjust the size of a text as you do, let's say, grow something. There is no action in there for that. But like Dan was saying, just use your attribute knowledge to adjust the text as you see fit.
Oh, I see what he's saying. He wants to know if it's smart enough to change dynamically, I guess, associated to a view, like, how Inventor does some things where you can actually have that label update. So you have section 1, and then the next one is section 2, the next one is section 3.
Oh, if I put it in, that's a good question. Now that I understand it, let's put another one in. I'm guessing no, or at least this one's built that way. This one's not built that way, but I'm going to guess no to that, but we can definitely look into it, because again, unlike Inventor, it's a standard block, and usually when you insert it, if you were to insert it from scratch, you would get prompted to change the text. It's not going to update automatically. So my first guess is no, but we can look at that further.
Okay.
Yeah, I agree. Too bad. Totally agree.
Yeah, well, that's why they have Inventor, right?
Exactly. Or AutoCAD Electrical. That does that too.
Yes. All right. I think that's a wrap, Ashley.
Okay, great. Well, this will conclude our broadcast. If you guys think of additional questions later, you can simply reply to the confirmation or reminder email that you received from GoToWebinar, and we can get those to Greg or your sales rep or whoever to get your questions answered. Once again, if you could take a few moments to fill out the short survey, we would appreciate it. It will just automatically pop up as we close down the session today. And thanks for attending. And you will receive an email tomorrow with the link for this recording, so don't worry about that. Thanks for attending, and have a great day, everybody.
Thanks, everybody.
Thank you, everybody.